In this video, we're going to talk about finding our absolute maximum and minimum values. We know that when we have a function, just depending on what that function is, we have maximums, we have minimums, but oftentimes we don't know necessarily where the absolute maximum, the highest point of the function reaches, or the lowest point, the absolute minimum. And so we know that sometimes we'll have local min and maxes, and actually the local min and maxes are going to be just the concave down portions of our function. And then whatever is the absolute lowest point and absolute highest points within a given interval are going to serve as our absolute maximum and minimum. So we're going to follow 3 very simple steps for this. We're going to find our critical points. So again, we're going to take our derivative, set it equal to 0 and solve. Find your critical points, and then if they fall within the interval, keep them. If they don't fall within the interval, throw them out. We're going to look at just plugging in the critical points and the endpoints into our function. Okay, so step 1, find those critical points within your interval AB. Step 2, plug those critical points into your interval endpoints into F. And then 3, whatever the largest value is, that's your absolute maximum. Whatever your smallest value is, that's going to be your absolute minimum. So let's check this out. These are pretty easy, pretty straightforward. Step 1, find those critical points. So I'm going to take my derivative here. We have 6x plus 2. I'm going to set that equal to 0. And we're going to solve for x. We'll get 6x equals negative 2. Divide by 6, divide by 6. We get x equals negative 1/3. Check to see if your critical point is within your interval. Clearly, negative 1/3 is between negative 3 and 5. So we are going to take our function, f, and we're going to plug in our critical point, and we're going to plug in each endpoint of our interval, and we're going to see whatever our largest number is, that's going to be our absolute maximum. Whatever our lowest number is, that's going to be our absolute minimum. So let's plug in negative 1/3 to begin with. So we have 3 negative 1/3 squared plus 2 times negative 1/3 minus 1. Well, that's going to give us 3 to the 1/9 plus negative 2 over 3 minus 1. So we get 1/3 minus 2/3 minus 3/3. So once we get all of this, it's going to be 1/3 minus 5/3, and then we get negative 4/3. So now what we can do is once we have the value of this, I can plug in each one of my endpoints, and we're going to see which one is the largest, and we're going to see which one is the smallest. So we'll plug in negative 3 next. So we have f of negative 3 equals 3x times negative 3 squared plus 2 times negative 3 minus 1. Well, that's going to give us 9. 9 times 3 gives me 27 minus 6 minus 1. So we're going to get 20. So f of negative 3 gives us 20. And then for our last one, we're going to plug in 5. So f of 5 equals 3 times 5 squared plus 2 times 5 minus 1. So 5 squared is 25 times 3. We get 75 plus 10 minus 1. We get f of 5 equals 84. So now when I look at my 3 solutions here, what is my absolute minimum? Well, my absolute minimum is going to be my smallest number. Well, negative 4/3 is going to be my smallest. So there's my absolute minimum. And my absolute maximum is going to be obviously my largest number. So that's going to be 84. And what we really care about here is stating it that your absolute minimum occurs at f of negative 1/3, and then our absolute maximum, f of 5, equals 84. And that's it. Very straightforward. Again, we found our critical points. It was within our interval here, so we kept it. Then we plugged all three of those numbers, our critical point and our end points of our interval, into our function, and we just found which one was the largest and which one was the smallest, and those served as our absolute maximum and absolute minimum. All right, so let's try one more here. So here we have g of x equals 3 times 4x plus 1 to the 4th power on the interval 0 to 2. So the first thing that I'm going to do is I'm going to take the derivative of g. We're going to get 12 times 4x plus 1 to the 3rd power times 4. Clean it up a little bit. We get 48 times 4x plus 1 to the 3rd power. And now we set it equal to 0 because, again, we're just trying to find our critical point. I'm going to divide both sides, and we're going to solve for x here. So we wind up with 4x plus 1 cubed equals 0. I'm going to take the cubed root of both sides. And we're going to solve for x, and we're going to see that obviously x is going to give us negative 1/4. So I ask myself, is negative 1/4 within my interval? Well, it's not, so I don't have to take negative 1/4 and plug it in to g, so that's very easy for me. All I'm going to do now is plug in my interval points into g, and whichever one gives me my largest number is going to be my absolute maximum. Whichever one gives me my smallest number will be my absolute minimum. So we have g of 0 equals 3 times 4 times 0 plus 1 to the 4th power. 4 times 0 is going to give us 0, so we have 1 to the 4th power times 3. Obviously, here we're going to get g of 0 equals 3. And then we are going to find g of 2. So we have 3 times 4 times 2 plus 1 to the 4th power. So obviously this one's already going to be a lot bigger. So we have 4 times 2 is 8 plus 1 is 9. So we have 9 to the 4th power, which gives us 6,561. We'll just write that out. So 6,561. And then we are going to multiply that by 3, and we get 19,683. And so I think it's pretty clear that this will be our absolute maximum, while this, it will be our absolute minimum. So again, I hope that this video helped you understand a little bit more of finding your absolute min and max and just the simple steps behind doing so. Just remember, find your critical points and see if they are within your interval. Then take your interval endpoints as well as your critical point, plug them back into your function, and whichever one gives you your largest number is going to be your absolute maximum. Whichever one gives you your smallest number will be your absolute minimum. It's that easy. So thanks for checking out the video. I'll see you guys next time.